In this video, we're going to be looking at differentiating polynomials, but of different varieties. So normally, we want our polynomials to look something like this, where we've got a term, where we've got a number out the front, we've got an x to the power of another number. But we don't always get this, especially with some of the exam questions. So let's have a look at a couple. We've got find dy by dx when y equals 3 over x squared. Now, this clearly isn't the form we want, so we're going to rewrite this. Now, this x, when we've got a divide by x squared, we can write this as a negative power. So we can write this as negative 2, x to the power of negative 2. Now, this is starting to look like, or it does now look like, our form we've got here. Some number multiplied by x to the power of something else. So we can now find dy by dx of this. So we are going to multiply by the power. So we're going to do 3 times minus 2. And we're going to decrease the power by 1. Well, if we're decreasing by 1, it's like subtracting by 1. So we're going to have minus 2, subtract 1 is minus 3. So we can rewrite this. 3 times minus 2, well, that's going to give us minus 6. And now we've got this power of a minus 3, so it's going to be 1 over, or putting the x at the bottom of our fraction, and we've got power of 3 here. Another one we've got is when we've got some brackets. So the first thing I'm going to do is expand those brackets. So 3x times by 5x cubed. The 3 times 5 is 15. X times x cubed is x to the 4. And we got 3 times negative 2, which is negative 6. And we're going to shove the x on the end. So we can find our dy by dx on this one. We're going to do 15 times 4, which is going to give us 60. We're going to decrease this 4 by 1, so it'll be a power of 3. And here, we're going to do our power, which is 1, times by minus 6, so it's just going to be minus 6. And if we're decreasing it, it'll go to the power of 0. So this is just going to give us our minus 6 here. Our final one is something like this. Now, it's going to look a bit of a beast at the moment, but we can sort this out much like we did above. And the first thing I'm going to do is actually split up the fractions. So I'm going to actually split this up into 2 fractions here. So the first one I'm going to be having as 10 over 5x squared. And then I'm going to be subtracting this 2x to the 4 over 5x squared. The denominator is the same on both. The numerators then get split up. So we can do what we did before with our powers of x. So in the first one, we've got 10 divided by 5, which is 2. And we've got this x squared on the bottom, so this is going to be x to the minus 2. We'll deal with the numbers on this second one, this second term. So we've got 2 over 5. Well, let's just leave this as a fraction. So 2/5. And we've got x to the power of 4 divided by x squared. So we are dividing terms with the same base. So we're going to subtract the powers. So we've got x to the 4 divided by x squared, which is x to the power of 2. So we can now find our dy by dx. We're going to take the first term, so we're going to multiply by the power. So we're going to got minus 2 times 2, which is minus 4. And then we're going to subtract 1 from the power. So minus 2 subtract 1 is minus 3. And for the second one, we're going to times by the power. So we have got this 2/5 multiplied by 2. So that's just going to affect the numerator at the top of the fraction. So that's going to go up to a 4. The denominator stays the same. And we're going to just decrease that power of x. So minus 4/5 x. We could rewrite the first bit, if we wanted to, as a fraction. And we can put the x on the top of our second fraction or something like that.